Good evening, everyone. I am Mr. Ish. Thank you for joining me on this video. We're looking here at vectors. We're basically starting out on the subject on vectors. There's a lot you can do with regards to vectors, with regards to how much you can present, especially at the high school level, and maybe you can say the first year college level. When you're talking about vectors, you're basically talking about a certain quantity, and this quantity is a means by which you can represent something important. Vector is a quantity such that it will have two properties to it. One will be the property of magnitude, that whatever it is that you're looking at, it has a certain magnitude, and then the second quality about that item that you're talking about, the quantity having two, one is magnitude and the other one will be direction. Anything which has both a magnitude and a certain direction is basically a vector. You would represent, like supposedly A represents a quantity which is a vector, you can represent it very well like with an arrow on top. What we want to do in this video over here is demonstrate how we can represent vectors, and then from there in the future videos on vectors we can add more to it. In this video we're basically just talking about vectors in terms of the basic understanding. If supposedly A is a vector, you can represent it in this form. It is made up of two parts. You have an A1 and an A2. A1, A2, and that's how you would represent a vector with having two of its items. But these items are by no means talking about magnitude and direction. These are the elements of the vector, because every vector you can plot it on a x and y plane. You can plot every single vector on an x and y plane. This can be representative of an x value, that can be representative of your y value. Given that little foundation, let's see what we can do with what I've presented so far. If we know that each vector can be presented in this element, let's show you something a little bit more numerical over here, and then we'll bring in the concept of magnitude and direction into this subject. If supposedly u is a vector which is represented by 1, 3, these are the elements. This right here is my u1 and that's my u2. You would go 1 and then you go 3 on the top. You'd connect from the origin to this point 1, 3, and that right there is a vector. That specific arrow has both a certain magnitude, it has a certain direction. How can you look at the magnitude in this specific instance? Well, you can look at it in terms of the length. The length of that arrow here will represent your magnitude. What about the direction? The angle of that arrow with regards to some reference horizontal line will be indicating your direction. If you were to take the angle right here from 0 degrees, this specific angle here, theta, will give you your direction. The length of this arrow will give you your magnitude. How do you actually bring these numerical quantities of magnitude and direction into life? This is how you do it. There's a formula for magnitude. The magnitude has a very simple formula, no different than the Pythagorean formula, but you represent it differently. For any vector which is represented normally by a letter u over here, right? You can use any letter, but here we have a specific vector, we're using u. You represent the symbol for magnitude like this, within two vertical parentheses, and then you give the formula for magnitude as u1 square plus u2 square, all within a square root. Here's my u1 square plus u2 square, all within a square root. Very similar to like a Pythagorean formula. Now, to demonstrate the angle of a vector in terms of its definition or formula, you always have to use the tan formula. Tan theta is always equal to the y value of your vector divided by the x value of your vector. Here, if this u1 and u2 are kind of synonymous with x and y, you're looking at u2 value divided by u1 value. Okay, so now we have the specific vector u, which is 1 and 3 represented in that way. Let's find the magnitude and let's find the angle, and you will very likely need a scientific calculator. If you're looking at here the magnitude of u, you're looking at u1 square plus u2 square square root. 1 square plus 3 square and root. You're getting a 1 plus 9, which is a root 10. So this vector has a certain magnitude, it's called root 10. Alright, now let's look at the direction of this. The direction of this is tan theta is equal to y over x, which is your u2 component divided by u1 component, which is 3 over 1. But you're doing tan theta is equal to 3 over 1. Therefore, theta is equal to arc tan or inverse tan 3. 3 over 1 is just a 3. You do the number 3 over here on your calculator, inverse and tan it, you get 71.56 degrees. So you're getting here a 71.56 degrees with regards to your horizontal. So this vector here, which is made up of u1, u2 component designated by the numbers 1 and 3, can now be written in this following way. It has a magnitude of root 10, right? And within now the parentheses, you bring in your direction. It is made up of a cosine 71.56 degrees and a comma. sine 71.56 degrees. If you were supposedly do this operation, multiply this with this and multiply this with that, you'll get 1 comma 3, and I'll show you that case. Then in the rest of this video we'll do some examples. Look right here, 71.56 cosine multiplied by square root of 10, I get a value here 1, so we're good. Now do sine of 71.56 and multiply by root 10, and I end up getting a value here 2.99, which is 3. So all of this is now beginning to make sense. So before we look at two questions, let's summarize some of these items we've learned. For a vector which has two components, a u1, a u2, which is your x and a y component, the magnitude, which is represented like this, is determined by u1 square plus u2 square root. The angle of that vector with regards to a horizontal line is represented as the inverse tan of your y over x, or your u2 component divided by u1 component. Once you've done all of these determinations, any vector right here can be represented by some magnitude, which I had in the previous example was a root 10, and then in your parentheses you put your cosine angle and you put a comma and your sine angle. Here I ended up having cosine of what I believe 70 something degrees and sine of 70 degrees. If you multiply this with that and you multiply that with that, you'll end up getting exactly u1 comma u2, and that's a verification procedure to show you that you are on the right track. So let's look at two questions now given all of this that we have, and it'll be very beneficial. Our first question is to analyze this vector A, which is made up of these components. You know, this right here is going to be my A1, that'll be my A2. By analyzing, we're talking about everything here. Well, we'll start by first determining the magnitude of this vector. You know it's going to be a 0 square plus 3 square, and you square root it. 9 square root is a 3. If you want, as a part of your analysis, you can very well graph it out. 0 comma 3, it's going to be an arrow which is pointing right over here. Just by looking at it, you know it's going to have a size of a 3, and it's going to have an angle over here of 90 degrees, which is pi over 2. But we'll determine that mathematically. And then, you know, the angle over here is going to be arctan, right? Arctan, your this component divided by this component. Now here you have a little bit of an issue. You know you can't divide a number by 0, right? You can't. So you know you're looking at some sort of quadrant angle, like a value which falls on one of your axes, either a y-axis on the top or on the bottom. So you plot it out on terms of this quadrant, and you realize your arrow is pointing directly north, upwards. So therefore that tells you right here that you're looking at 90 degrees, or you can say pi over 2. And how can you represent this? Now in terms of a good form, you can do like this: 3, your magnitude sitting outside, cosine 90 or pi over 2 comma sine 90, and here your analysis of this vector A has been completed. It has a magnitude, it has a direction of 90 degrees. Remember, all vectors are quantities made up of two items, two components. One is a magnitude, the other one is a direction. Our last question will be this: to analyze this vector V, it's made up of -3 comma -2. This you know is a V1, that right there is V2. If you want to start out with a graph, that's not a bad idea because it orients you to what you're looking at. 1 2 3 1 2 -3 comma -2. You're looking at a vector which looks like this. You have to find it with reference to a horizontal. Here's your angle, and you have to find its length. The length of this vector is very well the magnitude, which is by this formula. You'll do v1 square plus v2 square, and you'll square root it, and you'll get 3 square, which is a 9, plus 2 square, which is a 4. You get root 13. That's your magnitude of this vector. The angle of this is going to be arctan, right? Arctan of your v2 component, or your y value, divided by x value. You can just say v2 divided by v1, which is basically here arctan or inverse tan minus 2 divided by minus 3. You're doing minus 2 divided by minus 3, but the minuses cancel out. You can just do arctan of 2 divided by 3. Do 2 divided by 3 and inverse tan it. You get 33.69 degrees, but you're getting 33.69 degrees with regards to 180 degrees. You can add 180 to that, and you're getting 213.69 degrees. It's 213.69 degrees, but with regards to 0 degree reference angle. With regards to this, it's 213.69 degrees direction. Lastly, you can represent your entire vector in this form. Your magnitude, here you put cosine 213.69 comma sine 213.69. This is called like decomposing your vector, because you're decomposing your vector into its components. Now I've saved this value over here. We're completing this question by doing a check. we'll do our saved value 213.69, we'll cosine it, we'll multiply by root of 13, and I get over here minus 3, which is exactly what I want, minus 3. I'll do my saved value, my 213.69, I'll sine it, and I'll multiply by 13 root, and I should get here a minus 2, and there it is, and we're done. So remember everything you've seen in this video. Vector is made up of two items that have a good defined meaning, a magnitude, which represents here in terms of length for what we're looking at, and a direction with regards to a reference horizontal. It is made up of two components in terms of x and a y point of your coordinate pair, and you can evaluate that in terms of magnitude, in terms of direction, and then you can also analyze it in terms of a graph, x and y axis plane, and then lastly you can bring your components together into this good finalized form. Thank you for watching. Have a nice day.